Today we're gonna have a very quick explanation of a video I found, which was the death knell of gacha games. I'm gonna explain this in a very simple mathematical equation. So let's say you have like a two-dimensional function where this is fun of the game and this is not fun. And here it will be just the game state. So the state that the current game is in. Right? So the game can be in many different states, but now just to simply visualize this is just a visualization. The search space might be much bigger for a game like Arknights, but just to get my point over, let's say that we start here. We do it like this. So here we have two different. So here we have something called local minimum. So the local minimum is basically the minimum thing we can have if we gradient, if we take a point that we're currently in. This is, let's say this is Arknights endfield, and this is their beta. Let's say that. And before that, let's say they were here in the tech test. So this is like their alpha, let's simply explain for people who do not know what Arknights endfield is. And so after tech test, they took the feedback and they moved it over towards adding dodge, making more combat action oriented, etc. Right? And how did they do that, or how do we do that in mathematic forms? Right? Let's say this is a machine learning algorithm, for example. Well, we use something called gradient descent. I'm sorry, I'm making this video very spontaneous. Therefore, I'm writing with mouse instead of pen. What gradient descent basically does, you can search it up. It's a very it's a very fundamental concept in machine learning. But what it basically does, it evaluates the point that you're in, and it checks, well, how slow the slope is the point. Like how steep is the point, right? So basically, you can think of something like a tangent if you know about that, but basically the steepness of it, right? And so it sees the steepness of the current point that they're in, it's steeper in this direction, right? So what does it do? It will automatically move in this direction until it reaches a local minimum, right? Or it change until it reaches any type of minimum, right? And as you can see, the gradient descent will sort of be in here. It won't move anywhere else because going up means increasing the cost, basically, of our function. Basically, going up means that the game will not be fun anymore, right? So let's say that the gradient descent for our case scenario right now is player feedback. So player feedback is what is making our our point, Arknights endfield, to move towards this local minimum, which is similar to like Genshin action combat. Well, like this, let's say that this state is very similar to like Genshin Impact, um, Withering Waves, and stuff like that. What his point basically is in his video is that the Genshin formula might reach a local minimum where you can see that there is no other way for the game to be more fun than it currently is, right? But what the developers can do, or what they don't know, is that there is something called a global minimum, which is there exists a game state, like a state of the game, with different mechanics, maybe difficulty, stuff like that, right? That is more fun than the current state of the game that we're in, that we're headed to with this player feedback, right? But how do we move towards that state? Well, it's by adding experimentation, novelty, and stuff like that. So let's say that like the game starts moving in the other direction, where it maybe adds more complexity, more maybe some elements that make the game not fun at all. So we are kind of going up. So now because we're going up, the fun meter will be less. So the game will be less fun, right? But then they will reach a point where continuing going in that direction will actually yield more fun than the local minimum that we're currently in. So his whole point is basically arguing that endfield should strive to reach this global minimum instead of being stuck in this local minimum. One quick note I also want to preface is that this search space can increase. So, for example, by increasing it with another parameter, so let's say this is a two-dimensional search space, right? Let's say we have a three-dimensional search space, which means we introduce another parameter, which is game complexity, how complex the game is. Let's say that the game here is very, very complex, but it's not fun at all, right? So what do we need to do? Well, we lower the complexity of the game, which makes it so that we can reach into the fun level, right? But this is just a visual way of doing it in a 2D representation. We can add more parameters, for example, the novelty, how novel the game is, how easy it is to acquire materials. It could be anything you basically think of. And as you can see, we cannot no longer visualize it this simply in like a 2D, 3D plane or whatever, because the dimensions are as many parameters as there is. That was it for today. Now I gotta go to the lecture. Thank you everybody for watching.